Okay, so good day everyone. My name is Clarence Sagayno. I'm from BSCpE for 1 or Bachelor of Science in Computer Engineering for 1, and I'm from UP Santa Maria Bulacan campus. And this is my answers for my video answer or video explanation for my answers in these exercises. So coming in at the first exercise, which is the identification of addressing modes right here. So for each of the following instructions, identify the addressing mode used. So number 1 is mov AX BX. So answers to this is register addressing mode. This is because this is register addressing because both AX and BX registers inside the CPU. The CPU is just transferring data internally from one register to another. That's my number 1. So coming at number 2, which is mov AX bracket 1234H. My answer to this is direct addressing mode. And why is that? Because here the memory address is written directly inside the instruction, which is the 1234. This means the CPU does not need to calculate anything. It just goes straight to memory address 1234 and gets the value. So for number 3, the mov AL bracket SI. My answer to this is register in direct addressing mode. This is because the register SI doesn't hold data, but rather it holds an address. So the CPU looks at the value inside the SI, treats it like a memory location, fetches the data from that location. That is why it is called indirect or register in direct addressing mode. Because the register leads you to the data instead of holding the data itself, so it passes you to the data instead of you being passed on to the data itself. Okay, so coming at number 4. So my answer to this is base plus index addressing mode. This is because here the memory address is not directly written. Instead, the CPU adds two registers, which are the BP and the DI. This is usually used when dealing with arrays or structured data in memory, where BP might point to a base location and DI moves through elements. That is why my answer is base plus index addressing mode. So for the number 5, it's kind of the same, base plus index but this one with displacement addressing mode. With displacement is the keyword, and here this instruction or specific question has 3 parts. Number 1 is the BX, which is the base, the SI, which is the index, and the 08H, which is the displacement. So the CPU adds all 3 to calculate the final memory address. Then that is why it is the base plus index with displacement. So number 6 is register in direct addressing mode. So DI contains a memory address, so AX value is stored into the memory location that DI points to. Again, the actual address is not written directly. It's stored inside the register. It's like the number 3, register in direct addressing mode. So coming at number 7, my answer to this is base with displacement addressing mode instead of base plus index displacement. So why is that? So for number 7, here is the BP is the base register and 10H is a small offset or displacement. Then the CPU subtracts 10H from BP to find the memory location. That is why it's based with displacement addressing mode. This is common when accessing local variables in the stack. Then the number 8 is immediate addressing mode. This is because the number 5678H is part of the instruction itself. The CPU doesn't look at the memory or other registers. It just loads the value directly into AX. That is why it's called immediate. It's not closed or stored in a bracket or something. Then lastly, but number 9, my answer is register indirect addressing mode. BX, or in this case, BX holds the memory address of the data. It is also enclosed in a bracket. Then the CPU uses that address to get the value and put it into the AX. That is why it's register indirect addressing mode. So that's for the exercise number 1. Coming in at exercise number 2. So here, the exercise number 2's instruction is write code for specific addressing modes. Write 8086 assembly code snippets to demonstrate the following addressing modes. So number 1 is immediate addressing. Store the value of 55AAH into AX. So mov AX 0x55AAH. Why is that? Because the value is included directly, so no need to be fetched from memory, or no need to be get or to be led from somewhere. It's pretty straightforward. Then for the number 2, register addressing, copy the contents of BX into AX. Mov AX BX. Here is both operands are registers, so data moves internally inside the CPU. Number 3 is direct addressing. Mov AX 1234H, just like the earlier examples. So the CPU directly accesses the memory address 1234H. Number 5 is, or rather, number 4 is register indirect addressing. So the answer is mov AX brackets SI. It's because SI acts as a pointer to a memory location, or points the data or where the data could be obtained from that location. So number 5 is index addressing. Mov AL DI plus 10H. So here, the CPU calculates the memory address by adding 10H into DI. That's simple. That's it. The number 6 is last base index addressing. Mov AX BX plus SI. Here, the CPU adds BX and SI together to find the memory location. That's why it has the plus sign inside the bracket. That's my answers to exercise number 2. Moving on to exercise number 3, which is the address calculation. Here, given the base address of 1000H, segment address of 2000H, and a displacement address and the displacement of 0010H. Compute the physical so number 1's question is compute the physical address for the instruction MOV AX 1000H in direct addressing mode. So the formula here is physical address is equals to segment x displacement plus offset. So the solution is simply here provide the given. So the given is 2000 segment address, then base address or offset or is equals to the displacement, which is 1000H, and it's gonna be 10H here. So using the formula, 2000H times 10 segment times displacement plus offset, which is 1000, is equals to 21,000. Okay, so my answer is 21,000H. So for my number 2 is compute the physical address of mov AX BX plus SI plus 10H with BX. So the given here So using the formula, and this is the given, it's all in the instruction. So using the formula here, physical address is equals to bx plus si plus displacement. You'll get here 5565h. That's for the exercise number 3. It's repetitive. So exercise number 4, which is named as debug and analyze. Analyze the following code snippet and answer the questions. So here's the info. MOVAX brackets SI, MOVSI 2000H, ADDAX brackets SI plus 10H, MOV brackets DI AX. So here, number 1 is identify the addressing modes used in each instruction. So for these, I used the register indirect addressing mode because it is enclosed in a bracket. So the answer is not directly into this thing. It points you to where the memory or where the value is. That's why it's register indirect addressing mode. Then the next answer is that MOVSI 2000 here, it is called immediate addressing mode simply because the value is written directly or immediately. Then the number 3 is add AX or ADDAX bracket SI plus 10H. SI plus displacement, which is the displacement is the 10H. It's indexed with displacement. That is why the answer is indexed with displacement addressing mode. And lastly, move the brackets DI AX. Register indirect addressing mode. It's because DI holds address, which it directly translates into register indirect. So number 2, if the value at memory location 2000 is 1234H and at 2000 H plus 10H is 5678H, what will be the value of AX? So here AX is equals to 1234H plus 5678H is equals to 68 ACH. Here is AX starts with the value from the memory 2000 and it equate to 1234H. Then it adds the memory of 2010 or 5678H. So you just add those two and you'll get the answer 68 ACH. Okay. Then lastly, the number exercise 5 rather. Exercise 5, practical problem. Write a small assembly program that number 1 loads the value 0xabcd into the memory location 3000H. Number 2, retrieve these values using direct addressing mode and stores it in AX. Number 3, copies the value from AX BX using register addressing mode. And number 4, stores the value in BX at our memory location pointed to DI using register indirect addressing mode. So assume DI is equals to 4000H. So step 1 is pretty self-explanatory. Move AX 0xabcd. So this puts the ABCDH into AX and stores it in a memory location 3000H, which is here, of the value here, AX. This got encoded inside here. That's why that happened. So step 2, move AX 3000H. Now this loads the stored value back into the AX. Here, it got here. So number 3, move BXAX. Here, the values have been, or copies the value from AX to BX. And lastly, number 4, move DI 4000H, move bracket DI BX. It's because di is set to 4000 H. Then the value of bx stored into that memory location. And that will be all. I hope you understand my answers, sir, and thank you for listening. Have a nice day.